The normal distribution and the empirical rule. A special and very common type of distribution that is represented by a bell-shaped symmetric curve is known as the normal distribution. The normal distribution curve arises in many circumstances and describes many data sets concerning human characteristics such as height, weights, and scores on standardized tests. All normal distributions have the same characteristics. It's symmetric about a single peak. The single peak corresponds to the mean, median, and mode of the distribution. Since the mean, or arithmetic average, is the easier of the three measures of center to calculate, we will need to determine or calculate the mean whenever we have data that is normally distributed. The variation of the normal distribution is most commonly characterized by its standard deviation. There is also a special case of the normal distribution, which is called the standard normal distribution. The unique aspect of the standard normal distribution is that the mean is exactly 0 and the standard deviation is exactly 1 for this data set. Let's recap some of the key aspects of a normal distribution. First, most data values are clustered near the mean, giving the distribution a well-defined single peak. The data values are spread evenly around the peak or the mean of the distribution, giving the data a nice bell-shaped and symmetric look. Larger deviations or further data values that exist from the mean are increasingly rare, producing the tapering tails of the distribution. Since all normal distributions have the same bell shape, we can characterize the variation of any normal distribution with just a single number, the standard deviation. Recall that the standard deviation is a measure of the average spread of data values around the mean. A simple rule, called the empirical rule, gives precise guidelines for the percentage of data values that lie within 1, 2, and 3 standard deviations from the mean. By definition, about 68% of the data values fall within 1 standard deviation of the mean. Approximately 95% of the data values will fall within 2 standard deviations of the mean, and approximately 99.7% of the data values fall within 3 standard deviations of the mean. The next few slides will give us a graphical representation of this empirical rule. The empirical rule can also be referred to as the 68, 95, 99.7% rule. We always begin a normal distribution with drawing our normal distributions curve. Based upon the empirical rule, approximately 68% of the data is going to exist or lie within 1 standard deviation of the mean. Within 1 standard deviation means accounting for both above and below the mean by 1 standard deviation. Approximately 95% of our data in a normal distribution is going to lie within 2 standard deviations of the mean. And finally, approximately 99.7% of our data in a normal distribution lies within 3 standard deviations of the mean. It turns out we can utilize the empirical rule to answer many additional questions regarding the normal distribution once we take a closer look at the relationship between symmetry and this empirical rule. Recall the mean is the center of our normal distribution. Based on symmetry, this indicates that 50% of our data must fall below the mean. Everything under the curve must sum up to be 100%. If 50% of the data values fall below the mean, then based upon symmetry, we know that 15% of the data values must exist above the mean. Using the empirical rule and symmetry, we can determine the percentage of data values that fall between different standard deviations. Let's find the percentage of data that falls between the mean and 1 standard deviation below the mean. Let's begin by drawing our normal distribution curve. Based upon the empirical rule, we know that roughly 68% of the data lies within 1 standard deviation, or 1 standard deviation both above and below the mean. Using symmetry, we see that half the data is going to exist below the mean, and half the data must exist above the mean. In terms of a percentage, approximately 34% of the data lies between the mean and 1 standard deviation below the mean. Let's see one more time how we can determine the percentage between 1 and 2 standard deviations below the mean. Once again, we know that within 2 standard deviations based upon the empirical rule, that's going to account for roughly 95% of our data. Based on symmetry, right, half the data must exist below the mean, so that's going to account for 47.5%. We already found out, or we already figured, that between one standard deviation and the mean accounts for roughly 34% of the data. Therefore, the difference, or the remaining percentage, must be 13.5%. So 13.5% of the data is going to exist between 1 and 2 standard deviations below the mean. Using the empirical rule and symmetry, we can then conclude the following percentages under our normal distributions curve. Roughly 34% of the data is going to exist between the mean and 1 standard deviation, either above or below the mean. Roughly 13.5% of the data is going to exist between 1 and 2 standard deviations, either above or below the mean. Roughly 2.35% of the data is going to exist between 2 and 3 standard deviations, either above or below the mean. And don't forget about our tails. Roughly 0.15% of the data is going to exist beyond 3 standard deviations, either above or below the mean. Now let's take a look at some examples using actual data. We will walk through the first example together. The heights of women have a bell-shaped distribution with a mean of 161 centimeters and a standard deviation of 7 centimeters. Approximately what percentage of women are between 154 and 168 centimeters tall? Always begin a normal distribution example by drawing and labeling a normal distribution curve with the mean and 3 standard deviations both above and below the mean. We can then shade in the appropriate area under the curve based upon our question. We are interested in the percentage of women that are between 154 and 168 centimeters in height. Hopefully we can recognize this is within 1 standard deviation of the mean. So by the empirical rule, we can conclude that roughly 68% of the women are between 154 and 168 centimeters in height. Let's take a look at another example. The heights of women have a bell-shaped distribution with a mean of 161 centimeters and a standard deviation of 7 centimeters. Approximately what percentage of women are between 147 and 175 centimeters tall? Pause the video here and see if you can answer the question yourself before moving to the solution on the next slide. Once again, we're going to begin with our normal distribution and the mean and standard deviations labeled correctly. We are interested in the percentage of women that fall between 147 and 175 centimeters in height. This indicates that we are looking at the percentage of women that fall within 2 standard deviations of the mean. So based upon the empirical rule, we can conclude that approximately 95% of the women are going to be between 147 and 175 centimeters in height. Let's take a look at a few more examples. The heights of women have a bell-shaped distribution with a mean of 161 centimeters and a standard deviation of 7 centimeters. Approximately what percentage of women are less than 147 centimeters tall? Pause the video here and see if you can answer the question yourself before moving to the solution on the next slide. Once again, we're going to begin with our normal distribution labeled correctly. Shade in the appropriate region of what we're looking for. We are interested in the percentage of women that have a height less than 147 centimeters. So what do we know so far? Again, based upon the empirical rule, within or between 2 standard deviations above and below the mean, we know that roughly 95% of the data is going to exist. Because the total percentage under the curve must be 100%, that leaves 5% total, meaning 5% of the data must exist outside of 2 standard deviations above and below the mean, or in the tails. Based on symmetry, half the data must be on the low side, half the data must be on the high side. Half of 5% leaves me 2.5% of the data is going to be less than 147 centimeters. Or, based upon the empirical rule and symmetry, we can conclude that approximately 2.5% of women are going to be less than 147 centimeters in height. Let's take a look at one more example. The heights of women have a bell-shaped distribution with a mean of 161 and a standard deviation of 7 centimeters. What percentage of women are greater than 154 centimeters tall? Pause the video here and see if you can answer the question yourself before moving to the solution on the next slide. always begin a normal distribution example by drawing that normal distribution and labeling the mean and the standard deviations correctly. Highlight the region of the curve that we are interested in. We are interested in the percentage of women that have a height greater than 154 centimeters. We know that half the data must exist above the mean, or 50% of the data is going to be above 161. Between 154 and 161 centimeters is one standard deviation, which we've already determined based upon the empirical rule in symmetry. That must account for 34% of the data. Combining these two percentages, we can conclude that approximately 84% of women are greater than 154 centimeters in height.